Hi everybody, thanks for joining this new session with us today. That's the ultimate session of the Bonita Days 2018. I hope you guys get a chance to catch up a few sessions. The last 2 days I attended myself a few talks and it was really interesting. So to close this set of session today, we're going to talk about how we can help the companies to come and work together using new technologies. So to present that talk, it will be myself. I'm Lionel Palassin. I'm a technology evangelist for Bonita Soft. And today I'm really happy to share this talk with Sébastien Couture, who is a co-founder and work as a technology evangelist for Stratum. So Sébastien, if you want to say hi to everybody.
Hi everyone, glad to be here and looking forward to this webinar. Thanks to Lionel and Bonita for having me on this webinar today. Really excited about it.
Thanks, Sébastien. So yeah, we're gonna jump right away into the presentation. Just before that, 2 words on the logistic. We're gonna have like a 15-20 minutes presentation. Then we will do a demo for a solution we built using those technologies. And at the end of the session, we will have a dedicated time for the Q&A. So don't hesitate to use the GoToWebinar tool to ask any question you might have, and we will make sure at the end to answer all of them. The session is being recorded, so you will get a link with the video shortly after the session. If you have any trouble hearing me or seeing the slides, don't hesitate also to let us know. We'll try to arrange that. All right. So yeah, what I wanted to talk today with Sébastien is see how we can use a new technology to really bring companies to work together. And for that, I'd like to use an example, so to try to illustrate the cases where it can make sense to use such solution. And the example we're gonna take today is the construction of a new subway system. So let's say Dubai, it's an example, needs to build a new subway system in their city. So they will require different companies to work together to design the subway system. So this is what we call a consortium of companies when they got together and work on a common project. So in that case, we will see companies coming from Europe, coming from Asia, or from the US, or from different part of the world, and they will need to work together. So those companies don't really know how to work together. They don't really have their internal process aligned with the internal process of other companies. And when it comes to that specific example of designing a subway system, one of the key points will be to track any decision or any changes that can be made on the specification document. Let's say you have a document that will describe how what should be the measurement of the rails, and that is a really critical document, and it has to be shared by all the participants in the project for, by example, making sure that when the train is being built, well, it match the size of the rail. So it's just one example. And for that, we need to imagine what would be a system that helps those different companies to collaborate together on that project. So for that specific point, we can see different approaches. The first approach would be the point-to-point exchange. Let's say we have all the companies that will manage their own document, work on the specification documents with their own system, and eventually they will have to share or to get another company to validate one of these documents. So they will need to share it with this other company. So they can send it by email, they can share it through a central repository, they can have it delivered by paper, anything can be imagined. But what we are in the context of what we call the point-to-point exchange. At some point we pass a document to someone else. That can work. There is some risk associated. By example, we never sure at what point the changes have been made, who really made the changes. If I send an email to someone containing the document, how can I be sure that when you reply, the same document has been provided with the exact changes that we were required? So there is no really traceability of the events on a specific document. And we can't really trust the system. We basically trust the people, but we don't really have a solid ground that we can trust. Another approach will be for that consortium of companies to get together and create another company. So they will all put some time and money in that company, and that company will be in charge of providing a solution to manage all the documents related to the project. That can work. It's complicated to have all the company agree on the way that company should be running, how we're going to access the document to that company, how that company will work internally. We're going to have to spend a lot of time making sure everybody agrees on how this solution should be designed. So today we propose another approach. We propose an approach using a blockchain layer. So basically, we'll have all those companies being participants of what we call the private blockchain network. And the company will log on that blockchain the documents when they need other participants to either make change or validate the documents. Why a blockchain? So if you're not familiar with the concept of blockchain, don't worry, Sebastian will take time in a minute to describe exactly how we can use that. But basically, a high-level view is a blockchain is a decentralized storage where every event will be logged, timestamped, and added to a chain of data that is immutable. So we can trust that all the data stored on the blockchain will be trustable, basically. Why do we want a private blockchain instead of a public blockchain? Private blockchain allows us to control the number of participants. There are many advantages. First, the transaction. So each time we record an event to a document will be fast and cheap because we can optimize the transaction because we know the participants. We can make change easily. We just have to have everybody agrees on the change that have to happen on the blockchain to make them happen. And we can control who has access to the data that is stored on the blockchain. So to go a little bit deeper within that blockchain layer, I will let Sebastian explain that to you.
Thank you, Lionel. So I suppose that most of you here in this webinar have a pretty good understanding of the basic value proposition of what a blockchain is, but I'd like to maybe do a little analogy, and we can build a blockchain together. I usually do this with like a room of people where we can interact. I understand that I can't really interact with people here, so just sort of hear me as we walk through this. So, you know, a blockchain is really the construction of a blockchain really much resembles the way that we come to consensus and agree on historical facts. So, you know, we all know that Christopher Columbus discovered America in 1492, and we all know that U.S. gained independence in 1776, and we all know that France had a revolution in 1789, and I'm not going to surprise you when I say that Canada was confederated in 1867. And similarly, it's no surprise to anyone that the First World War started in 1914 and that man landed on the moon in 1969. So effectively, as long as we all agree on this, we have a consensus around historical facts, and that consensus is secured by everyone observing the facts and then coming to consensus and making those facts available for others to see them. So now, if I try to convince you all that the French Revolution started in 1992 rather than 1789, most of you will look at me and just sort of discard that what I call a fact, but what you would in fact call a lie, right? And so, much like with the blockchain, participants of a blockchain come to consensus by observing a fact, by verifying that that fact is true, and then by spreading to other nodes in the network this fact, this historical fact. In the case of a blockchain, typically it's transactions or data, and spreading that data to other participants in a way that they can verify it themselves. Now, you'll say, some of you will say, yeah, but some people think that man didn't land on the moon, or some people maybe argue that this fact didn't happen then, or happened at another time, or some people think the Earth is flat. Well, that's all true, but in reality, those groups of people represent a marginal fraction of society, and so therefore their opinions very much don't affect the more broader consensus. So we see this in blockchains. Some of you may be aware of the fact that Bitcoin, the public blockchain Bitcoin, has forked. Also, Ethereum has forked. So in the case of Bitcoin, we have the Bitcoin Cash blockchain. The Bitcoin Cash blockchain is essentially a fork of Bitcoin where a portion of the network says, hey, we don't agree with the rules of this blockchain, this original Bitcoin blockchain, so we'll create this other blockchain. Now, we could argue about the value of Bitcoin Cash for days, but the valuation, which is about somewhere around 10% of Bitcoin, shows you that the level of influence of that blockchain is a lot less than the original Bitcoin. So there are a lot of parallels here about sort of how we construct historical facts, and blockchain just sort of organizes that in a way that we can have historical a single source of truth about the history of transactions, and it does this in a way that involves making it automated by computers and algorithms and digital signatures. So with that sort of high-level overview out of the way, I'd like to spend a minute to tell you a bit about Stratum and proof of process. So Stratum is a company that's just about 2 years old, a little bit over 2 years. We're based in Paris. We are a team of about 20 people at the moment. And Stratum builds technologies that allow for companies to better collaborate amongst themselves, with their partners, their customers, and the regulators. And we implement a protocol that we invented called proof of process. And proof of process is a protocol that defines how organizations can collaborate in this way, and how these organizations can come together around a timeline of historical facts in a way that we know who did what at what time, in what order, and for what reason. And this is very useful for, if we come back to the idea of Bonita and Bonita is extremely useful when the pain point is like, how do I organize this process that I have internally, and how do I get my internal stakeholders to collaborate on this process, and all the tools and the low-code application development tools that Bonita provides fulfill that need. What Stratum, if you compare that to Stratum, what Stratum says is, how do I solve that problem when I'm dealing with multiple entities, multiple independent entities that have independent business models, incentives, etc., interests, and how do I come to consensus around the data that they provide in a common process? And there are many applications of this in industries like trade finance. We work an awful lot in insurance. Two of our lead investors are insurance companies. We're also backed by NASDAQ. And the technology that we provide is enterprise software to organize this consensus of data amongst stakeholders in a process that spans across company lines. So I think we can move to the next slide. So in a nutshell, the value proposition of Stratum is that for one, we simplify regulatory compliance procedures for companies that have to interact with other companies. And one example of this is a project that we led in France with 14 insurance companies. I'll spare you the details. There's more information on our website and on our blog about this project. But essentially, French insurance companies are required by regulation to collaborate on a certain number of processes, one of which is customer mobility. So if one customer wants to move from one insurance company to another, the customer doesn't have to do any of that paperwork or any of that administrative work. The insurance companies are required to essentially collaborate to make the contract is transferred. There's no coverage. Any critical customer data gets transferred to the insurer, etc. And so this is a regulatory there's regulation around this process, and companies have to be compliant with that process since it is regulated, and there are potentially fines at stake. And so we simplify that by providing the auditors and regulators with the audit trails that allow them to verify that all the steps were done in accordance to this regulation. We also realize that blockchain networks are often touted for their transparency. So if you look at something like Bitcoin, for instance, all transactions are transparent. In a consortium network, such as the one that I just described, this is not always desirable. So, for instance, if you have 14 insurance companies and 2 of them are interacting in a transaction because a customer is moving from one of those companies to the other, well, I don't want all of the other insurance companies to know and be able to do business intelligence and espionage on my internal processes. I want that data to be protected. All the while, I want to be able to prove that I'm in an ecosystem where everybody is following the rules. And so we provide that with some very clever cryptography and some more advanced technologies like zero-knowledge proofs that allows me and another participant in a process to interact in a way that the data is encrypted, while other participants can still validate that my interactions are regulatory compliant, even though they can't actually see the data. And the goal of this, of course, is to digitize processes and automate processes in a way that the ultimate goal is for operational costs to go down, error handling costs to go down, data consolidation costs to go down, and all of the frictions that exist today because this would be antiquated and sometimes even archaic middle and back office systems, that we can reduce these costs significantly by implementing these technologies.
Sounds good. Thanks, Sebastian, for this detailed explanation. And I think now everybody can understand better what is the benefit of using the Stratum technology and how it can make sense in the exact use case that we were discussing previously. But there's still some challenge remaining. Of course, Stratum will provide all the technology to quickly deploy the blockchain layer, connect the different participants. But we still have a need to for each participant to interact with that blockchain, and that's what we're gonna call the client application. And the client application in such a big solution will most likely be pretty complex. You will need to translate complex business logic, you will need to integrate third-party system as well as a blockchain layer. The third-party system will most likely be a legacy system, especially when it comes down to document management in big company. We can end up dealing with old systems, and we need a flexible solution that will basically orchestrate the different tasks that need to happen internally before we reach the blockchain layer and register an event, right? Another big challenge will be to ensure that the users, when the application is deployed, like the solution and interact with it in a efficient manner. So we need a solution that has the knowledge of what it means to build a business application that is modern, responsive, flexible, and smooth enough for the users to like interacting with it. And finally, we always want to control the cost of implementation and maintenance, and that's where a low-code approach will also most likely make sense, because we can speed up the development, we can collaborate, we can imagine of different companies collaborating on some part of the client application if there is a common part. So that's why we think like the Bonita platform is a really good candidate to build the client application, because they will have the tools to integrate the blockchain layer, they will have the knowledge to build, to provide a good experience to the users, and they will also have the flexibility to integrate the third-party system. So that's why we decided to create a partnership with Stratum. So basically, we build prototypes and we start working with customers to build a complete solution that will use both technology and both technologies' advantages. So in this demo, you will see how we build a prototype to manage documents between different companies, and we build the application client with Bonita and the blockchain layer with Stratum. So you will see that in a minute in our demo. But first, let me walk you through why we really decided to use Bonita as a client application. So first, as I said, for the integration layer, we build a set of connectors to store documents in AWS S3. So that's our architecture choice for that specific demo. We basically store all the events or the metadata related to a specific document in the blockchain, and we store the physical document or the electronic version of the document in a S3 bucket, which is a shared storage system. So we basically have Bonita that orchestrates those different actions, and they provide connectors to quickly integrate the Stratum APIs layer, and connectors to integrate quickly with AWS S3. Here the collaboration part can be interesting because the same connectors can be used by different companies to build similar solutions. So we don't need to reinvent the wheel each time we build a new client application. The second point is the power of process design. So it's a more abstract approach, but basically we know by experience working on a lot of customer projects with Bonita that a process design approach is a strong way of implementing or making sense of complex business logic. It's much more easier to have a room of people from different departments in a company agree on a visual process that you can turn in an application quickly to make sense of those business logic. So that process design approach, we believe in it when it comes to build the client application side. And another concept that we found interesting when we were building the prototype is the process design and the blockchain share a common concept that we call the always forward movement. It's pretty simple. When you have a process, you basically go from from a start event to a task, and then to another task, and then gateway, you eventually take another route, and you eventually end up on end event. So you will start from somewhere to go somewhere, and you always move forward. When a task is done, you go to the next task, and so on. And even if you come close to reach the end, you're not going to say, oh, I want to go back in time and change the outcome of a specific task that have already been executed. This is not conceptually what the process design allows. And it's the exact same thing with blockchain. In addition, that in blockchain, it's ensured by the implementation of blockchain. When you interact with a blockchain, you always add data to it. You add data to the chain. And it's not possible to come back in the past and say, oh, I want to change the data stored in that specific block that has been added to the chain 2 weeks ago. The blockchain, by design, won't allow you to do that. So that's really interesting when you build application that needs to interact with the blockchain to already have this concept, this common concept.
If I can just, add on that, we often get this question as like, okay, so I've got a blockchain now. There's going to be some data in there, and then at some point, what if I realize that data was wrong and I need to change that data? Well, that's okay. I mean, you can always write a new step to say like that the data has changed, but you will preserve the audit trail of that change. And so it's very similar to the way that so we revise history. To come back to the example, at some point, like we had certain notions about the way the world worked, or about physics, or even the fact that the world is flat. But then we learn new things, and then those things now become common knowledge, like the world is round, for instance. I mean, we don't discount the fact that at some point we thought the world was flat, but now we have a new reality. So that's very similar to the way the blockchain works. We'll always have that old piece of information, but we have the trace that it was amended.
Yeah, definitely. That's a great analogy, and I think it helps really understand the concept. Thank you. So just before we go to the demo, last concept is, how they said previously, we will need to make sure that the users will interact efficiently with the solution. And it comes usually with a price, and that price is usually the knowledge of how to build efficient application. You want a smooth experience, so you want a smooth integration between all the systems that need to interact with the application. You want the application to be portable and responsive. You want it to work on your laptop, on your phone, on your tablets, and all of that. Bonita platform already has that kind of feature built in, so you really remove that from your thinking when you come to design the client application. So without waiting, we'll give you a quick demo of what we built. So it's basically a prototype of document management. So here I have one application. It's built on top of Bonita. And just to replace the context, we're trying to build a subway system between different participants. So at some point we need to exchange documents between them, and we need to track all the changes on that specific document. So I have a first application that is built on top of Bonita, and as a, let's say, the person in charge of designing the rail, I want to send the document to another company so they can validate the size and the measurement of the rail. So I would create a new project, and I can add documents where I say rail specs, and I can add that. Can you create the measurement? Okay, so I can send that, and automatically the document will be sent to another company, and we will have an event logged on the blockchain. So you have a second app for the company that will review the document. So when the document has been submitted, we will see that they get automatically a new task. So that is all managed by the client application side. So we create basically a new process and we assign the task to a specific person within that organization. That person can review the documents and reject it, for example. You can say this is not the right size. So that's pretty simple concept. Basically, we navigate between application and we can interact with the document. Now that person can see that the document is here waiting to validate. But the interesting part is where is the blockchain in all that story. So here we can see that we can consult the story of a document, so we can see what happened exactly on that specific document. So I created as Lionel Palassin, and Philippe Lomé, who is a reviewer from the other company, rejected the document. But we can see the history in Bonita application, but we can also consult it directly in the blockchain. So here we directly have access to the blockchain UI. Maybe I will let Sebastian describe you what's happening on that side of the application.
Thank you. So in effect, so what this layer provides is it provides the single source of truth, which is provided by the consensus in the blockchain network. So each participant in this process, so each company has a blockchain node and participates in validating transactions and validating the data that is sent to the network. So what you see here is the auditing tool that is provided by Stratum. Our blockchain technology layer is called Indigo. That's our implementation of the proof of process protocol, and this is the agent, the Indigo agent UI. And what you see here are different steps in the process, so the initialization, adding the document, and reviewing the document. And so if you click on the first step, so what we see here is the data being added to this step, as well as the fingerprint of that data. And if we click now on the evidence, yes, on the evidence tab.
My bad.
We'll see that this has been complete, and so if we then click on the JSON tab, here we have the actual transaction hashes as well as the signatures that were involved in adding this piece of data to the blockchain. Now, this is all very technical. I'm not going to go into detail about what we're seeing here, but essentially every step in this process includes the data along with the proofs that it was validated and added in the consortium blockchain network, and makes reference to the previous step. So we know that the add document step came after the initialization step, and sort of and does so in a way that if someone changes the data in the initialization step, the reference to it in the document added step will no longer match. So it creates this immutability aspect that is important if we want to be able to trace a process and ensure that none of the data has been amended over time. Exactly.
So that's exactly what happened on the blockchain layer, and we can see that thanks to that we can really create immutable audit trail. It really matters when it comes down to manage documents between different.
Just if I can just interject here on the operational point of view, the agent Indigo agent UI interface is not necessarily something that would be made accessible or should be made accessible to operations teams. So the operations team should use the Bonita application, but now an auditor or an auditing engineer can go in and verify that information should there be an audit, or should that information need to be reported to some sort of an authority. So at no point should the operations team necessarily have access to that very technical blockchain data, but it is accessible if necessary by the people that it concerns.
Yeah, no, that's it. Yeah, thanks for the clarification. Yeah, we built the demo to make it easier just to access the blockchain data through the application. But yeah, in a real life, it wouldn't be exactly designed like that for sure. That's about it for us. I think now we gonna give you the audience some time to ask any question, unless you have something you want to add before we close, Sebastian.
No, that's it. For me, I mean, what I'd like maybe to close on is if you're interested in what we're doing and would like to learn more about the proof of process protocol and our offering, you can go to stratum.com and learn more there. And also on our blog, blog.stratum.com, we have a few articles describing this process in particular in detail and other use cases in insurance.
Sounds good. So maybe Nicola, if you want to help us with the question, if you see any questions by the audience.
Yes, sure. So a couple of posted questions here. One is asking, do you have a token or a coin? From Olivier. And also, are you built on top of something like Ethereum?
No. So the Indigo stack is actually it's meant to be deployed in a consortium setting. So it doesn't rely on public blockchain networks. So it's very different from the way public blockchain networks work, and really much relies on independent actors that know each other and that want to participate actively in a shared process. So in that sense, there is no token. There's no need for a token because the validation logic is very different. The consensus model. I don't want to go into too much detail, but on a public blockchain network, you sort of need that. You need a token as an incentive mechanism for the validators to validate the transactions in a process called mining or perhaps proof of stake validation. In a consortium network, the actors know each other. They are made part of the network from the beginning, so the network knows who has access to the data, and so therefore we simply rely on a very simple voting mechanism. If anyone is interested in the technology that's behind the Indigo stack, it's the Tendermint blockchain, but that's our implementation. We're very much agnostic to the blockchain technologies themselves. We can work with enterprise Ethereum, or we can work with Hyperledger Fabric. It's very much a question of what technology matches the need.
Okay, I think we have another question, which is why, or are you able to deploy the solution only on AWS? Why not Azure? I think that's for the cloud solution. So that's a good point. Maybe I can answer for the Bonita part, and Sebastian, you can answer for the blockchain part, as the entire solution right now is hosted on AWS, and we specify the word AWS S3 during the presentation because that's the bucket we use. It's definitely not mandatory. It was just easy for the prototype. We could also have the option of storing all the documents on the blockchain, but I will maybe let Sebastian elaborate on that part. We can definitely deploy the Bonita part solution on AWS or Azure. It doesn't really matter for us.
Yeah, so on my side, the blockchain nodes themselves, so the participants in the network deploying nodes can be deployed on any infrastructure, AWS, Azure. In fact, we have a partnership with Azure where you can, like in the Azure Marketplace, you can deploy your Indigo node very easily. or even on your own infrastructure, your own private cloud. The Indigo node is a Docker container essentially, so you can deploy it anywhere you like. So the data that is stored in the blockchain itself can live anywhere, and the participants themselves will have their own infrastructure. So one node might be on Azure, another company might have a node on AWS or some other service. In this case, I think, if I'm right, the documents themselves, so the actual PDF files, were stored on AWS.
Yes.
Ideally, and this is something that we're working towards on the roadmap of future versions of Indigo, is to also have decentralized document storage. Because the blockchain stores data, but it's not very good at storing like large binary files like a PDF. So we're working on having distributed or decentralized data storage integrated within Indigo, so something like an IPFS, where the documents would be distributed, and we wouldn't have to rely on some sort of central document storage system.
Sounds good. Thanks for the answer. I don't see any other question on my side. Nicola, do you see other question?
Yes, looking at the question queue here, there's a question from Sergio asking, participating companies in the implementation should be part of the ledger storage network?
Sorry, could you repeat the question?
Sure. So he's asking if participating companies in the implementation should be part of the ledger storage network?
I'm not exactly sure what the ledger storage network means. I presume the person means, do the companies participating, do they need to host a node in the ledger? It's really a matter of the governance system. So it comes down to who's a stakeholder and who has enough at stake to want to validate the transaction data. In an example such as this, we could assume that all the companies involved in validating documents could have nodes where they store and validate the transactions. But in other use cases, in other applications, say for instance in insurance, we could rely on a network where the 15 biggest insurance companies in the country run the network, and then smaller insurance companies that want to access the data could simply access that data as non-validated nodes, and perhaps even pay for access to that data. It really depends on the application that we're building. There's no cookie cutter answer.
Sounds good. Thanks. I don't see other questions at this point, and we are about to be right on time for the webinar. So if you have any further question, Nicola actually copied a link to contact us at Bonita Soft. If Sebastian, you want to quickly copy in the chat a link to contact Stratum in case anyone has a specific question about Stratum technology.
The best way to reach out to us is on our website. There's a contact page there. You can reach out to us there, and I personally take those emails, so I'd be happy to answer any of the questions you might have.
Sounds good. Thank you everybody for joining us today. Thank you, Sebastian, to co-host this webinar with me today. I wish you all a great end of day or a great day, depending where you are in the world. And hopefully I'll see you really soon.
Thank you.
Thank you.